Okay, so today we are going to learn how to graph quadratic functions. Technically, we already learned how to graph them in lesson 8.1, but when we did it in 8.1, you were given the domain values and you calculated the ordered pairs through a table, and then you took the ordered pairs that you calculated in the table and put them into the coordinate plane. Today, we are going to essentially do the same thing. However, we're going to take into consideration that we have an axis of symmetry or a line of symmetry going through our parabola. So the warm-up here is exactly what we did in the homework. They're asking us to find the axis of symmetry, and they're asking us to find the vertex. Now, just to demonstrate this, when I was first looking at this with my A period this morning, when we first started to set up the equation to find the axis of symmetry, when I first did it, I made a mistake in finding the value of B. So let's see if you guys can catch this. What is my A in this equation? The 4. What is my B value?
0.
Excellent. Okay. What happened was we thought the B value was the -7. Remember, the B value is the number in front of X. Notice this equation does not have an X term. So my B value here is 0. There's no X. So then when you do the equation, the negative B over 2A, you're putting 0 over 2 times 4, which 0 divided by anything is just 0. So that's how they get the axis of symmetry of x equals 0. So be very careful when you're looking for your A and your B value. Remember, the A is the number in front of x squared, and the B is the number in front of x. Then for the second part, I'm just going to jump down and do number 5. We just demonstrated this when we did the homework. So we are going to take our equation, y equals x squared plus 4x plus 5. I need to find the vertex. Remember, the first step, though, to find the vertex is to plug it into the axis of symmetry formula. So I'm going to identify that my A value is 1 and my B value is 4. So I'm going to put in here -4 over 2 times 1. -4 divided by 2 gives me -2. So my axis of symmetry is x equals 2. And I've already started out getting my first part of my vertex. It's -2. I now just have to get the y. And remember, to get the y, you take the original equation, and I'm going to replace both of my x's that I have here with the -2. -2 squared plus 4 times -2 plus 5. And I'm going to follow PEMDAS here. Exponent first. I can multiply over here, and then I will work left to right. 4 plus -8 is -4. Drop down the plus 5, and my y value is 1. So now in my ordered pair, I put a 1 there. And that's how you find the vertex. Okay, good so far? So this start is just a review. So now we're going to actually try to graph it using a little bit of a shortcut instead of creating a whole table. Now, before we can begin the process of finding the axis of symmetry and the vertex, make sure your quadratic function is in standard form. And remember, standard form is written from greatest to least based on exponents. We have the ax squared plus the b term, and then the c. So an example could be x squared plus 3x plus 4. That would be standard form. So greatest to least based on the exponent. So here are some graphs. So far in the two previous lessons, we didn't talk about the y-intercept. We talked about the x-intercept. That's where the zeros were. But now today, we are going to find the y-intercept as one of our points that we're going to graph. And the easiest way to find it is it's going to be our c term. So if your equation's in standard form, your y-intercept is right here. So if I were to write an equation here, notice this one right here. I have the equation y equals negative 2x squared minus 6x minus 3. Notice the very last term, my c term, is my y-intercept. Notice that my graph is hitting the y-axis right here at negative 3. Notice in the middle box, the very last term in my equation is plus 4, so that is my y-intercept. So the very last number is going to tell you where your graph hits the y-axis. Notice this one has negative 2 here, so right here. And it's always the constant. It is the number that doesn't have a variable. Okay, if you have an equation like this, y equals x squared minus 2x, where is your y-intercept? What's your c term? 0. Everybody see that? There's nothing there. There's no constant. So your y-intercept on this equation is going to be 0. All right, so let's see this in action. The first thing we're going to do when we're going to use this new technique is to find the vertex. Now, the steps to find the vertex are the same thing we did last night for homework. So let's go ahead and let's work through this. So we have 3x squared minus 6x plus 1, and it's y equals. The first thing we need to do is find the axis of symmetry. So I'm going to use my negative b over 2a. I'm going to identify my a term and my b. So my a is 3 and my b is negative 6. Now I'm going to put it into the formula. So opposite of b will become positive 6, and then 2 times a, which is 3, and then I'll multiply and divide. My axis of symmetry is x equals 1. I now need to find the y to my vertex. I take the original equation. You are going to take out the letter x's. And you are going to put in x equals 1. So in place, so now I'm going to do y equals 3 times 1 squared minus 6 times 1 plus 1. 3 times 1 squared is 1 minus 6 times 1 plus 1. Work left to right, and you can see that y equals negative 2. So my vertex is the ordered pair 1 comma negative 2. Good so far? All right, let's go back to the equation real quick before we start go any further. Based on my equation here, is my graph going to be up or down? It's going to be up because this number is positive. So this would be a quick way that you can check that after you get some more points, that if your graph doesn't look this way, then you've done something wrong. The second point we're going to look for is the y-intercept. So far we've got 1 point to start making our graph, and it's the vertex. Step number 2 is to find the y-intercept. Okay? What did I tell you the y-intercept was? It's the c, so it's this last number. So the y-intercept is 1. Everybody see that? So now I have 2 points. I have my vertex and I have my y-intercept. So now I'm getting points without making a whole table. Now, the next step, it's up to you which x's you're going to plug in. So next step is to find 2 more points. Okay, they're recommending that you find it on the same side of the axis of symmetry. Remember, our axis of symmetry is x equals 1. So I'm going to pick 2 numbers that are either bigger than 1 or smaller than 1. And then I'm going to plug them in. So they're choosing to do x equals -1, and x equals -2. So now you're going to take your original equation, the 3x squared minus 6x plus 1. So essentially, what you did in this table back in lesson 1, we're doing without a table. So here, we're putting -1, or actually, since we're picking -2 and -1, we've already done 0, because that was the y-intercept. That one was an easy one to figure out. And then we already got 1, because that was our vertex. So now we've got 4 numbers. I know when we did it in 8-1, we had 5 numbers. But once I apply the line of symmetry, I'm going to end up with 6. And I'll show you what I mean by that. So let's go ahead and plug them in. So they're just doing, instead of doing the work in here for the -1 and the -2, we're going to do it over here to the side. So 3x squared minus 6x plus 1. We're going to plug in -1. Follow order of operations. I need to square first, and then multiply, and then I get 10. So now this one is a 10. Then I'm going to go and do the same thing, but this time I'm going to do the -2 and plug it in. I didn't leave myself very much room here, so I'm going to squeeze it in here. -2 squared minus 6 times -2 plus 1. Exponent first, and then multiply, and then get 12. Did I do something wrong? No, it's good. So then plus 12 plus 1, and it's 25. So now I have 4 points. Now I'm going to my coordinate plane. I'm going to graph these. So on the slide, here is what they've graphed. They've graphed the vertex in blue. They graphed the y-intercept in red. And then in pink, the other 2 problems or points that they found. Notice when I connect these points, I do not have a U shape. I've got half a U. Everybody see that? Notice through my vertex is my line of symmetry. To get the right side, here's how I'm going to come up with the right side. I'm going to figure out how many spaces away is this red point from the green line. You see how it's 1 space away? So then on the other side, I can go 1 space away and put a dot right there. Then I can come up to this pink one. 1, 2 spaces away. So over on this side, I could go 1, 2 spaces away and put a dot. So this is how you could use your line of symmetry to get more points. And then up here, I'll go up to the 25, or the -2, positive 25. It's 1, 2, 3 spaces, and do the same thing over here. Now I can connect my dots, and now I have the right side of my parabola. So we will connect it and make your U shape. And there is your parabola without doing a table. Remember, on the quiz, I am going to give you a table, I am going to give you the x's to plug in. You are going to do the calculations to get the ordered pairs. Then you will take your ordered pairs and graph them on your coordinate plane. If you look at the slide, the right side over here has the complete graph. So when you connect it, remember we determined at the beginning, based on this number, because it was positive, that we should have had a U shape. If it were negative, you know it should have been an upside down U. So this is another technique for graphing without creating a whole table of values. Let's do another example. Now, notice here's the helpful hint. So because your parabola is symmetrical, each point is the same number of units away from the axis of symmetry. So it's like a reflection. So it's like a mirrored image. That's why we can do this to get some more points on our graph. So let's try this one. This one's actually going to give us a negative fraction, a negative mixed number. Okay, your axis of symmetry can be halfway through. It could be 1.5. It could be 1 1/4. The axis of symmetry can occur anywhere as long as it's through the vertex. So let's try this one. So again, just like last night's homework, we are going to find the axis of symmetry first. Our A term is 2, our B is 6. We're plugging it into this formula. Opposite of B is -6, 2 times 2. So we end up with -6 over +4, which gives me -3/2, which turns into -1 1/2. Now, when you plug it back in for the x to get y, you can either plug it in as the improper fraction, as a mixed number, or even a decimal, whichever you're more comfortable working with. So if I take my original equation, and now I'm going to replace the x's with -1 1/2. I'm actually going to plug it in as the fraction. So I'm going to do 2 times -3/2 squared plus 6 times -3/2 plus 2. When I square this, it becomes 9/4. When I multiply this, and I get -3/2. Let me just put it as a fraction. So now I'm going to start simplifying. This could become a 2, so this is 9/2. This is actually going to simplify, and I get -9 plus 2. I'm going to make my 9/2 into 4.5. Minus 9 plus 2. Now I'm going to follow PEMDAS. I'm going to work left to right, and I get -4.5 when I group those, plus 2. And now I'm doing -4.5, and I'm going to subtract this, and I get -2.5. So my vertex is -1.5, comma, -2.5. That's my first point. Now, what is my y-intercept? 2. Good. So now I have ordered pair number 2. I've got 0, 2. To get 2 more points, I'm going to pick 2 numbers that are either bigger, pick 2 numbers bigger than -1 1/2 or smaller. So you could either pick -2 and -3. I'm going to actually pick 1 and 2. So I don't have any negative numbers to deal with. So the numbers I'm going to pick for x are x equals 1 and x equals 2. Again, it's up to you when you're doing the homework tonight. So I'm going to take 2x squared plus 6x plus 2. And I'm going to do this 2 times. Let me fix this. So 2x squared plus 6x plus 2. So 2 times 1 squared plus 6 times 1 plus 2. 2 plus 6 plus 2, and I get 10. Over here, I'm putting in a 2. Exponent first. Now multiply, and I get 22. So now my 2 ordered pairs are going to be, that I'm adding to my list here, are 1, 10 and 2, 22. So now I have 4 points. I'm going to graph those 4 points and then find the ones on the other side to make it look like a mirrored image. So let's try that. So here they've done the work for the vertex. I already did that. Here is the y-intercept, and here are the 2 other points. They actually picked -1, +1. Their graph is going to look similar. So first thing you're going to do is graph the ordered pairs that you have, and they did that. So let's see, they did that over here. Here is the vertex in blue. Then from there, they went to, let's see, let me erase here. So the vertex was -1.5, -2.5. One of the other points they calculated was -1, -2, and then the other one was 110 like we did. Notice the y-intercept is 2, and it's crossing it. To get the left side, remember you're going to count the spaces away. So you could put another point right here. That would be symmetrical to this one. And then you can put, this one's like half, so 2.5 away. So you could also put one over here and get your other side of your U. And that's what they did here. So we're reflecting the points across the axis of symmetry, not across the y-axis, but across the line of symmetry. Notice this one, this example, it's not in standard form. We need to fix it first, and then we can begin our process. And here it is in standard form. And then from there, find your axis of symmetry, plug it in, get your other piece of your vertex. From there, find the y-intercept, and then from there, pick 2 more points. After you have those 4 points, you are going to graph them, make either the left or the right side, and then reflect to get the other side. The other thing that you're going to have in the homework tonight, the last question, is an application problem. You are doing the exact same thing in this word problem. You are going to find the axis of symmetry first in the word problem, then you are going to find the vertex. Once you do that, it's going to answer all of the questions. So this one, they're throwing a basketball in the air. The equation that models it is this. The equation that will model it is going to be, the equation that we're going to use to model it is this. We're still going to find the axis of symmetry and vertex. So here they are finding the axis of symmetry. They find x equals 1. And that's going to be the time it takes for that basketball to get to its highest point. After we plug it in and get the y, this is how high the basketball goes. And then it's going to take another second before it hits the ground. So when you're doing this, this is the graph, or this is what it looks like. You throw the basketball in the air, it gets to its highest point, and then it comes back down to the ground. This vertex tells us, the 16 tells us how high it got, And the first number, the x, tells me how long it took to get 16 feet in the air. So when you're asking how high does it go, it's the y of the vertex. How long it took to get there is the x of the vertex. And then to get back down to the ground, you would just take that x and times it by 2. Or find your intercept down here. So that's how you can model a real world application. Remember, the vertex is the highest or the lowest point. So here, Molly is diving into her pool. So she's going to jump off the diving board. She goes up, and then she splashes in the water. So to figure out how high, the maximum height of her dive, again, we're going to get the vertex. The y gives us the height. The x gives us the time. So we're going to find the axis of symmetry first. Plug it in, get the y of the vertex, and then from there we can answer the questions in the word problem. So tonight's homework is going to be 3 questions long. You are going to come up with your ordered pairs so you can graph your function. The last question is the word problem. Again, do the same steps. Find the axis of symmetry, find the vertex. Once you do that, you can answer the questions. Any questions on this homework? All right, so there are a few more examples you can read through here. This is still Molly's dive. They actually have a firework question also, and it's showing the firework shell and how long it takes to get to the highest point. So you can work on your homework. You only have a few minutes. And if you have any questions, you can let me know. Monday, we will reinforce this, and then Tuesday, we will begin reviewing for your quiz, which is on Wednesday.